Hi, Phil.
Hey, Christian.
Thank you once more for being back.
It's always a pleasure.
So I don't know if you've seen, but on LinkedIn, I have advertised that I'm trying to understand like the mechanical aspect of my 3D printer.
Yep.
There's a lot of chemistry around 3D printing, like the how the resin is, what components are in the resin, but I can't quantify any of that in my home. But I can quantify all the mechanical aspects. And so far, I've just been running them on whatever they asked me to. But being an engineer, I couldn't stop myself. Like, could I tweak this? Could I make it better? So I've thought, okay, let's do a scientific experiment on all of these or some of these, because actually it's summed out to being 11 factors. So I want us to try and limit this as much as possible.
I'm sure they all have some effect, but the first objective would be to find the few factors that have the most important effect using a screening design.
Okay.
And then we can augment on that later to learn more.
That sounds good. These are the 11 factors that I have defined. Most of these are from the settings on the machine, and then I've added to myself. So we have things like the height of every single layer. And you can see if a specific layer is only 0.02 high, it will take significantly longer time if every layer is 0.1.
Yeah.
Because if you see if there's 100 layers of one and it has to be reach the same height, I will need to do 5 of these for every of these.
Yeah.
So okay. As what you can see here, my responses, one of my responses is printing time. Because if this was like a production setup, time is money, and I want printing time to be as low as possible. However, I want quality to be as high as possible. But these are the factors. Now, as I was discussing this with subject matter experts on Reddit and LinkedIn, they said, well, these two are actually just the first layers that ensures the whatever you're printing will stick. So the first like 6 layers has an exposure time of like 40 to 80 seconds, where every single layer by itself will only be maybe 6 to 10 seconds. So you really burn in those first layers to ensure you have a good adherence to the build plate. But
right.
They don't really talk about, they don't really define anything else than is it sticking? So if it's sticking, then these are set correctly and they don't really tell anything more. So like these can easily be removed from the DOE. So when I defined all the excess, I was like, okay, well, I also need responses. And it took me a long time to try to figure out, I wanted something measurable that we can optimize. And what I got to is I found this on the internet, the lovely internet, and it's a thing you can print. And this is then supposedly 4 millimeters. This is 6 millimeters, and this is 8 millimeters. So I have those 3 things that I can measure with a precise micrometer, and I can also weigh this to see whether it has the same weight every time. And more than that, so that's 4 things I will be measuring, and then I'll also be measuring the printing time. Okay, any comments or thoughts so far?
No, that all makes sense. It sounds like you've got some responses that you can measure that are meaningful to you.
Well, actually, before I do this, I will do a MSA on my micrometer. So I'll try. Nice. I want to see what is the uncertainty of my measurement, because I know if you're not certain about your measurement, none of this matters. Like you'll just be modeling noise, right?
Totally.
So, what design should I choose?
So you could use a definitive screening design, would lend itself to this. As I said, your primary objective is going to be screening.
All right. So instead of talking about it, let's just try and make a definitive screening design and see how it looks, because I know that design is really easy to make.
Yeah.
So we go to definitive screening, and I say, because I have my responses there, I can just click the load responses. I have printing time to be minimized. I have these 4, 6, and 8 to be match target. And in a similar manner, I can load the factors in by going to my factor table, saying load factors. Okay, and these are the, nice. I'm not totally confident these are the ranges that I'm going to set, but that doesn't really matter when we're setting up the design. I can always change the highs and lows.
Right.
And I continue. As I stated many times before, I'm cheap, so I'll go to no extra runs. All of these are easy to change, so there's no need for blocking. And I'll say make design. It gives me 22 different runs. For me, that's quite a few runs. I mean, it's at least 66 hours of printing time. It's 21 times I need to clean the printer, level the bed. So I don't know. This would be a powerful design, I'm sure. But if we should go smaller than this, would that be a bad idea?
Well, the nice thing about a definitive screening design, one of the things that people really like about them is that for your continuous factors, you're testing at 3 levels. So you're testing a low, a medium, and a high, which means that you can model if there's a curvilinear relationship between your response and your factors. So I think basically if you want to go smaller than this, the compromise that you're going to make is that you won't be able to look for those curvilinear relationships. We'll just be looking at the linear relationship between the factors and responses.
And I would actually assume most of these have a curvilinear effect because all of these are set around the optimal settings. So I've gone the middle, all of these middle points would be the normal running condition. And then I've gone up and down. And I'm suspecting that too little is not a good idea and too high is not a good idea. Not being sure about that. So that's a trade-off I don't want to do. Like I need to see those curvilinears. Could we do a 2-level screening and then augment that?
Yeah, you absolutely can. So I would probably go to the custom design platform to do that. If you want the absolute minimum size.
Yeah.
So again, you just need to load in your responses and your factors as you did previously. And so what you've got there, you've loaded your responses and your factors, and with a custom design, you need to tell it what model you're wanting to estimate. And typically for a screening design, we say we just want to estimate the main effects, which is the default model that Jumper's put in there. So you've got one main effect for each factor. And so the minimum number of runs that you can do is the number of factors that you have.
Okay.
Plus 1 for the intercept.
Plus 1 for the intercept, yeah. So that would be cutting it close.
Yeah.
Doing the tip, but that's significantly cheaper than 21.
It is, yeah. I mean, and this, again, we're thinking sequentially here. This isn't going to be the end of it. But the compromise here is we're trying to find the factors that are active. You might find light off time. You might see no effect between the low and the high setting of that. So you would declare that as being inactive, and then we'd kind of forget about it for the rest of the experiment. But it may be that actually there was a maximum in the middle of the range that you haven't looked at because we're only looking at this is just going to generate a 2-level design.
Okay.
So that's kind of the compromise. It's often about managing the risks and your uncertainty and your comfort and what you're expecting.
So for these, what you're saying to me is that because this is so custom, I could actually say, well, I want powers to do curvilinear, but I don't want all of them.
Yep.
I know, for example, room temperature, the temperature goes up, the viscosity of the resin goes up. That's a good thing for 3D printing. So I'm actually assuming that's not going to be curvilinear. If I'm having it at a really low degree, like I said, 10 Celsius, I can't do 10. I might be able to do 15 Celsius. I have a controlled environment where I can set the temperature. That's going to be bad, but higher is always better.
Okay. Yeah, so it's just going to be like a linear or very close to being a sort of linear increase.
So I could remove that. And right now I have minimum 17. So if I'm removing that, you're telling me the minimum would then be 16?
Yep.
And there we go. So if I can, with my expert knowledge on 3D printing, remove some of these because I know they're not curvilinear, I'm actually saving myself time and
Yeah.
money. Okay.
And there's even an additional option here is that you can change them from being necessary to if possible. So if you've kind of got a little bit of uncertainty about whether it might be important or not, you can change it from necessary to if possible.
So if this light up time was like, I'm not really sure, I think change that to if possible. Okay.
Yeah, and it won't increase the minimum number of runs, but if it's possible to generate a design that can potentially estimate it, it will.
It will. Okay. So what if I just did a response service model and took all of these except all of these as if possible? Doesn't allow me to do that.
I think it's asking too much, really. I mean, yeah, there's just such a huge number of effects there.
Yeah.
I'm not sure how well that's going to really.
So that would only work if I increase this significantly.
I would think so.
Yeah.
Yeah. I haven't really tried such an extreme example.
And it's just like being cheap. Like you're saying, I can put things in as if possible. I'm going to put everything as if possible.
Yeah.
Yeah.
I mean, there's no harm in it. It's going to be optimal for the necessary effects that you've specified.
But another way of looking at it, if I, again, know with my expert knowledge that some of these are interaction, I would then add that. Like if I know, okay, layer height and exposure time I know it's there. I would then add it because then I know I have the needed run to identify that as well.
Yeah.
And
definitely.
then this is not, if this was not enough, I could then augment it.
Yeah.
Oh yeah, I'm actually liking this design better. We're down to like minimum is minimum, but could we do minimum plus 1?
Yeah, absolutely. The default is generally the minimum plus 6 or thereabouts. I can't remember exactly how the algorithm works, but it's, the idea is you want a few additional runs to properly estimate the error, assuming you're going to fit that full model with all of those terms, and having some estimation of the error alongside that is generally a good thing. But
I know I'm not going to be estimating the full model. Some of these will be not insignificant. That's just, for me, a significant decrease.
Yeah.
And there might some of these that comes off as not being significant at all. And I would be able to remove those and then build upon it with augmentation.
Yeah. I think it comes down to like how much do you actually know about this system or process ahead of the experiment. With a definitive screening design, it's essentially doesn't really require any knowledge of the process or system other than just the ranges that you're going to use. If you've got more understanding about which effects are more likely to be important that you really do need to estimate, then you can build that knowledge into a custom design and do it more efficiently.
And ultimately saving time and money. And
exactly.
Yeah. And if you're aiming for augmentation, you might as well try and cut it small and make it and then build upon it.
As we say, all models are wrong. Some are useful. So it's really, I think the end point is when you've got a model that's useful for you, that's, in your case, a model that gives you a useful understanding of how to optimize your 3D printer setup.
Yeah.
It might be that just those 17 runs gives you all you need, but it might be a longer, more sequential process as well.
I'm hoping those 17 are not.
I'm hoping they're not, because it'll be more interesting.
Yeah, sure. All right. Well, thanks, Bill. I'm gonna go with the 17 because that is I was like, hey, definitive screening, that works. But then when we went into the custom, you saved me 15 hours of cleaning and stuff and resin I need to pay for. So that's a great.
Cool.
Now I just need to go and do it.
Yeah.